Space, the final frontier. For as long as humanity has looked to the skies, we've wondered what lies beyond our planet. From ancient civilizations charting the stars to modern-day astronauts venturing into the cosmos, space exploration is one of humanity's greatest quests. Join us as we take you on a journey through the entire history of space exploration, from the first tentative steps into space to the ambitious missions that will shape the future of humankind. Welcome to the entire history of space exploration.
The 20th century marked a monumental turning point in human history, one where the boundaries of our world were shattered and humanity's gaze turned upward toward the stars. The dawn of the such space age came not just as a leap in technology, but as a profound change in the way we viewed our place in the universe. It all began with a single moment, the launch of an object that would change everything. Before the space age officially began, the idea of traveling into space was largely confined to the realm of science fiction. For centuries, humankind had dreamed of venturing beyond the Earth, with stories of flying machines and lunar expeditions captured in books and imagination. Writers like Jules Verne and H.G. Wells sparked the imaginations of people around the world, laying the groundwork for what was to come. Jules Verne's 1865 novel, From the Earth to the Moon, depicted a fantastical voyage to the moon aboard a giant cannon-fired capsule, while H.G. Wells' The First Men in the Moon introduced the concept of a space-bound rocket. These early stories weren't just flights of fancy. They inspired real-world pioneers such as Robert Goddard, often called the father of modern rocketry. In the 1920s and 1930s, scientists began to turn these theoretical ideas into reality. Robert Goddard, an American physicist and engineer, became the first person to successfully launch a liquid-fueled rocket. On March 16, 1926, in the desert of New Mexico, Goddard's rocket soared 41 feet into the air, paving the way for the development of future space travel. Though his work was initially met with skepticism, Goddard's innovative experiments were crucial in demonstrating that rocket propulsion could be used to reach space. His work laid the foundations for the technology that would one day send humans beyond the Earth. However, it wasn't until the Second World War that rocketry took a significant leap forward. The war's demands for advanced weaponry led to rapid advancements in rocket technology, most notably with the development of the V-2 rocket by Nazi Germany. The V-2, created by Wernher von Braun and his team, was the first long-range guided ballistic missile and marked a key turning point in the development of space exploration technology. The V-2 rocket's ability to reach altitudes of 176 kilometers over the Kármán line, the internationally recognized boundary of space, made it the first human-made object to reach outer space. While it was used as a weapon during the war, the technology behind it would eventually be repurposed for peaceful space exploration. After World War II, the United States and the Soviet Union began a race to harness rocket technology for peaceful purposes, particularly in the fields of science and exploration. The defining moment of this new era came on October 4, 1957, when the Soviet Union launched Sputnik 1, the first artificial satellite into orbit. Sputnik's launch was a groundbreaking achievement. This small, spherical satellite, no bigger than a basketball, orbited Earth at speeds of over 29,000 kilometers per hour. It emitted a rhythmic beeping sound, which was heard by amateur radio operators worldwide. But its significance went far beyond its size or sound. For the first time in history, humans had sent a machine into space, marking the official beginning of the space age. Sputnik sent shockwaves throughout the world, but none felt it more than the United States. The Soviet Union's success in launching the satellite ignited fears in America, fears of a technological gap, and more pressingly, the possibility that the Soviets might use space technology for military purposes, potentially even launching missiles capable of reaching U.S. soil. This event forever changed the geopolitical landscape, propelling both superpowers into a fierce space race. In the wake of Sputnik, the United States was forced to accelerate its space program. In 1958, the U.S. government established the National Aeronautics and Space Administration, NASA, an independent agency tasked with overseeing all civilian space activities. NASA's primary goal was to demonstrate American leadership in space and to catch up to the Soviet Union's advances. NASA's first major space initiative was the Explorer program, which aimed to launch a U.S. satellite into orbit. In January 1958, Explorer 1 became the first successful American satellite, and it also made an important scientific discovery, the Van Allen radiation belts, which were named after the scientist who first identified them. Explorer 1's success marked the beginning of the U.S.'s determined push into space, but the stakes were even higher than before. The race to dominate space would become a battle not only of technological achievements, but also of ideologies. The space race was not only about space technology, it was a reflection of the ideological and political battle between the capitalist United States and the communist Soviet Union. Both nations realized that reaching space before the other would not just prove their technological superiority, but also demonstrate the strength of their political systems. As the Soviets kept achieving space milestones, the U.S. was in a race against time. On April 12, 1961, the Soviet Union achieved another milestone. Yuri Gagarin, a Soviet cosmonaut, became the first human to journey into space aboard Vostok 1. Gagarin's flight, which lasted 108 minutes, orbited the Earth once before safely returning to the surface. The Soviet Union had once again pulled ahead in the race to space. Yuri Gagarin's achievement was not only a monumental technological breakthrough, but also a victory for the Soviet regime. Gagarin became a symbol of Soviet prowess, a hero not just in the USSR but around the world. For the United States, this marked yet another defeat in the increasingly intense space race. While the Soviets were achieving remarkable feats in space, the United States wasn't far behind. In 1961, American astronaut Alan Shepard became the first American in space, though his flight was suborbital and only lasted 15 minutes. Despite this, it was a crucial step forward for the U.S. space program and helped restore American confidence. Shepard's flight marked the beginning of Project Mercury, a program designed to develop the necessary technologies to send humans into space. Following Shepard's success, NASA would go on to achieve even greater milestones in the years to come. Closing thoughts. For Chapter 1, the launch of Sputnik and the ensuing space race were not just the beginning of space exploration, they were the catalyst for a new era. The technological breakthroughs that occurred in this period laid the foundation for every subsequent achievement in space. Humanity was no longer grounded by Earth, we had become spacefarers. The journey to the Moon, Mars, and beyond had begun. The space race began in the wake of the Cold War, a competition not just for political supremacy, but for technological dominance. The Soviet Union launched Sputnik 1 in 1957, marking the first time an artificial satellite entered Earth's orbit. The world was stunned. The United States was caught off guard, and the space race began in earnest. Sputnik 1 was just the beginning. In 1959, the Soviet Union achieved another milestone with the Luna 1 mission, the first spacecraft to reach the vicinity of the Moon. And Luna 2 in 1959 was the first to crash land on the Moon. These early Soviet successes spurred the U.S. to accelerate its own space program. While the Soviets took the early lead, America responded with its own ambitious plan, the Mercury program, the U.S.'s first manned spaceflight program. On May 5, 1961, Alan Shepard became the first American in space, orbiting the Earth aboard Freedom 7. Kennedy's bold vision for the U.S. was to land a man on the Moon. The Apollo program, born from this vision, saw multiple uncrewed missions that tested spacecraft and rocket designs. The culmination of this ambition came with the launch of Apollo 11 on July 16, 1969, with astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. Armstrong and Aldrin's historic moonwalk, the first time humans set foot on another world, was a defining moment not only for the United States, but for all of humanity. The 1970s marked a shift from the ambitious moon landings of the Apollo missions to more sustained, long-term exploration. In 1973, NASA launched the Skylab, the first space station that provided astronauts with a platform for conducting scientific experiments in low Earth orbit. Skylab proved that extended stays in space were possible, but it was the Space Shuttle program that would revolutionize human spaceflight. In 1981, NASA launched Columbia, the first reusable spacecraft which provided unprecedented access to space. It was capable of carrying astronauts and cargo to orbit and returning safely to Earth. The Space Shuttle played a critical role in deploying satellites, conducting science experiments, and constructing the International Space Station, ISS. It was a symbol of the continued efforts of the United States to push the boundaries of space exploration.
However, space exploration was not without its dangers. On January 28, 1986, the Challenger space shuttle tragically exploded shortly after launch, killing all 7 crew members aboard. The disaster deeply affected the space community and led to a reassessment of NASA's approach to spaceflight. While human space exploration has been limited to low Earth orbit, robotic spacecraft have ventured farther into the cosmos. The Voyager missions launched in the 1970s are among the most successful deep space missions to date. Both Voyager 1 and 2 were tasked with exploring the outer planets. Voyager 1, which is now over 14 billion miles from Earth, is the farthest human-made object from our planet. It carries with it a golden record, a message to any potential extraterrestrial life, containing sounds and images from Earth. Meanwhile, on Mars, robotic explorers like Spirit, Opportunity, and Curiosity have provided valuable data about the red planet's geology and its potential for past life. In 2021, NASA's Perseverance rover successfully landed on Mars, bringing us one step closer to understanding the planet's history and whether it might have supported life in the past. As we step into the 21st century, space exploration is experiencing a paradigm shift. Once the sole domain of governmental agencies like NASA and the Soviet space program, the final frontier has now become an exciting arena for private enterprise. This new age of space exploration is being driven by visionary entrepreneurs, whose ambition and innovation are pushing the boundaries of what's possible. One of the key pioneers of this new era is Elon Musk, whose company SpaceX has dramatically changed the landscape of spaceflight. Founded in 2002, SpaceX set out with an ambitious goal to make space travel affordable, reusable, and sustainable. At the time, the idea of private companies launching spacecraft seemed almost impossible. SpaceX's journey began with the Falcon 1, the first privately developed liquid-fueled rocket to reach Earth's orbit. However, it was their breakthrough innovation, the Falcon 9, that set the stage for a revolution. Unlike traditional rockets, the Falcon 9 was designed to be reusable, a radical shift that has since reshaped the economics of space travel. In 2015, SpaceX made history when its Falcon 9 rocket successfully landed back on Earth after launching a payload into orbit. This feat marked the first time a rocket had returned safely to the ground after completing its mission. This achievement not only saved millions of dollars per launch, but also paved the way for future missions with reusable technology. SpaceX didn't stop there. In 2020, SpaceX made another giant leap with the launch of the Crew Dragon spacecraft. This marked the first time a private company had launched astronauts to the International Space Station. The mission, called Demo 2, was a critical success and solidified SpaceX as a leader in human spaceflight. SpaceX's Crew Dragon spacecraft was designed not just for government contracts, but for the future of private space tourism and space travel for all. This mission was an important milestone, showing that private companies could carry humans to space safely and effectively, opening the doors to future commercial ventures.
But Elon Musk's vision doesn't stop at low Earth orbit. His ultimate goal is to send humans to Mars. In 2019, SpaceX unveiled the Starship, a fully reusable spacecraft designed to carry up to 100 people on long-duration missions, including the goal of establishing a human settlement on Mars. Starship, currently in the testing phase, promises to revolutionize space travel by offering an affordable and reusable solution for interplanetary voyages. Musk's dream of a self-sustaining colony on Mars could one day become a reality, expanding human civilization beyond Earth and creating a backup for humanity in the face of global challenges. Another key player in this private space race is Blue Origin, founded by Jeff Bezos, the billionaire founder of Amazon. Blue Origin has a similar vision to SpaceX, but focuses primarily on developing reusable spacecraft for suborbital space tourism and beyond. Blue Origin's New Shepard rocket, which has successfully completed several test flights, is designed for suborbital space tourism with the potential to take paying customers to the edge of space for a few minutes of weightlessness. Bezos's long-term vision is for human civilization to thrive in space, with large colonies living in orbit, working in manufacturing, and perhaps even extracting resources from asteroids. In 2021, Bezos himself flew aboard New Shepard, marking a significant milestone in private space tourism. This flight, which took just over 10 minutes, was a demonstration that space tourism is not a distant dream, it is already beginning to become a reality. A third major player in the commercial space industry is Virgin Galactic, founded by British entrepreneur Richard Branson. Virgin Galactic is working to make space tourism a luxury experience for private citizens, with flights reaching the boundary of space, offering passengers the chance to experience microgravity. Virgin Galactic's VSS Unity has made several successful test flights, with Branson himself becoming one of the first private passengers to reach space aboard the spacecraft in 2021. These trips don't involve orbital travel. They offer a glimpse into the future of commercial space travel for civilians, with the promise of making space accessible to a select group of people. These companies are part of a rapidly growing space tourism market, where the idea of traveling to space is no longer confined to astronauts or government missions. Private companies are not just looking to make space travel accessible for the wealthy, they are working to drive down costs so that it can one day become available to the masses. Looking further ahead, the potential for space exploration grows even more exciting. Concepts like space hotels, commercial space stations, asteroid mining, and even lunar tourism are no longer science fiction. The moon could become a tourist destination, and mining asteroids for precious resources like platinum and water could become a viable business. Innovations in space propulsion, artificial gravity, and life support systems will shape the future of interplanetary travel. The next few decades could see the creation of permanent human settlements on the moon, the construction of orbiting space habitats, and even the establishment of the first human colonies on Mars. The possibilities are limitless. Private companies like SpaceX, Blue Origin, and Virgin Galactic are leading the charge, but government agencies like NASA, as well as international partnerships, will continue to play a pivotal role in supporting these ambitions. At the heart of this new era of space exploration is the idea of sustainability, using the moon and Mars as stepping stones for deeper exploration into the cosmos. Space exploration is no longer just about looking up at the stars. It's about reaching them. And the dream of becoming a multi-planetary species is no longer a distant fantasy, but a rapidly approaching reality. One of the most profound questions in space exploration is whether we are truly alone in the universe. The discovery of exoplanets, planets that orbit stars outside our solar system, has provided new hope that life could exist elsewhere. In 1995, astronomers discovered the first exoplanet orbiting a sun-like star. Today, thousands of exoplanets have been identified by missions like Kepler and TESS, some in the so-called habitable zone, where life-supporting conditions might exist. Projects like the Search for Extraterrestrial Intelligence SETI continue to scan the skies for alien signals, hoping to find proof that intelligent life exists beyond Earth. One of the most ambitious and exciting initiatives for the future of space exploration is NASA's Artemis program, a bold plan to return humans to the Moon. Since the last Apollo mission in 1972, the Moon has been largely forgotten in our quest for deeper space exploration. But now the Moon is once again at the forefront of our space ambitions. NASA aims to land the first woman and the next man on the Moon by 2024, and this time, the goal isn't just to explore, it's to establish a sustainable presence. With the Artemis program, NASA is laying the groundwork for the next chapter of lunar exploration. A lunar gateway will be built in lunar orbit, serving as a staging point for missions to the lunar surface and beyond. By establishing bases on the Moon, NASA hopes to build a long-term infrastructure that will allow astronauts to explore the lunar surface for extended periods. The Moon's south pole, where water ice is believed to be abundant, is a prime location for human exploration. This water could be used for drinking, creating oxygen, and even generating fuel for rockets, a critical resource for further space exploration. The Artemis missions will also serve as a testing ground for technologies needed to sustain human life in deep space, such as closed-loop life support systems, habitats, and spacesuits. These innovations will be crucial for future Mars missions, making the Moon the first stepping stone in humanity's larger journey to the Red Planet. While the Moon offers a relatively close destination for humanity's first forays beyond Earth, it is Mars that has captured our imaginations as the next home for humanity. Mars is the most Earth-like planet in our solar system, and is seen as the next great frontier in the quest to become a multi-planetary species. NASA's Perseverance rover, which landed on Mars in February 2021, is conducting critical research to understand the planet's geology and climate, and to search for signs of ancient life. Perseverance has also been tasked with collecting soil samples for future return to Earth and testing the technology to produce oxygen from the Martian atmosphere, a crucial step toward sustaining human life on Mars. However, sending humans to Mars will require overcoming many challenges, from the vast distance to the harsh environment. Mars is over 200 million kilometers away from Earth, meaning a one-way trip could take anywhere from 6 to 9 months. This will require advanced propulsion systems, radiation protection, and sustainable life support systems to ensure astronauts can survive the journey and live on the Martian surface. SpaceX and its founder Elon Musk, whose long-term goal is to send humans to Mars and establish a permanent colony. SpaceX's Starship rocket is designed to carry large payloads and crews on interplanetary missions. It's fully reusable, which could dramatically reduce the cost of deep space travel. With Starship, Musk envisions a future where humans can settle on Mars and begin building self-sustaining colonies. The idea is to create a new society on Mars that can thrive independently of Earth. Colonists would live in pressurized habitats, grow their own food, and mine the Martian surface for resources. While this vision may seem like science fiction, SpaceX is already testing Starship prototypes with the aim of launching missions to Mars within the next decade. If successful, these missions could lay the foundation for humanity's first steps on Mars and the beginning of what could one day become a thriving Martian civilization.
One of the most exciting frontiers of space exploration lies in the concept of asteroid mining, the idea of harvesting resources from asteroids that could be used to fuel future space missions or even benefit life on Earth. Asteroids are rich in valuable resources, including metals like platinum, iron, and nickel, and even water, which could be used to fuel rockets or sustain life in space. Companies like Planetary Resources and Deep Space Industries have proposed missions to prospect and mine asteroids, potentially unlocking vast new resources that could fuel space exploration for generations. While asteroid mining is still in its early stages, the potential for it to reshape the future of space exploration is immense. With the ability to mine asteroids for fuel and resources, humanity could one day establish permanent colonies on the Moon, Mars, and even in the asteroid belt, all without relying on Earth for essential materials. As exciting as the exploration of the Moon, Mars, and asteroids is, humanity's ultimate goal may lie beyond our solar system. The idea of interstellar travel, exploring planets and star systems light years away, has long been the stuff of science fiction. But advances in propulsion technologies are making this dream more plausible than ever. NASA's breakthrough. Starshot initiative is a project aiming to send small, lightweight spacecraft to the nearest star system, Alpha Centauri, within a generation. By using powerful lasers to propel tiny sail-equipped probes at speeds close to 20% the speed of light, Breakthrough Starshot hopes to open a new era of interstellar exploration. While we are still far from achieving true interstellar travel, the quest to explore planets orbiting other stars known as exoplanets is already underway. With missions like TESS Transiting Exoplanet Survey Satellite,